Good evening and welcome to the Dark Art of Container Monitoring with Chris Crane from Sysdig. My name is Henrietta and I work on the community team here at eSynergy Solutions. eSynergy specialise in open source and cloud resourcing. If you're looking for a new opportunity, we can help you find the right role tailored to your skills and experiences on either a contract or permanent basis. So please send over your updated CV. Should you be looking to build out your team, we can help you with hiring and attracting top talent. Alongside this, we can also help you with upskilling your employees around the latest open source and cloud technologies. Now, moving on to some housekeeping. If you have any questions for Chris, please fire them over via the question box throughout, and he will answer them at the end of his talk. We are recording this session and the slides and recording will be made available and sent to you tomorrow by email, along with my contact details. Now I'm going to pass over to Chris to begin his talk.
Hi everyone, my name is Chris. Let me just get my slides going here and I'll jump right into it. All right, cool. Hopefully this is coming through clearly. Yeah, good evening everyone. Thank you so much for joining. My understanding is that probably most of or everyone on this call is calling in from the UK or from Europe. So thank you for joining in and joining the meetup a little late in your day. Hopefully everyone had a good day and hopefully I can top it off with some interesting information for you here. So we are here today to talk about monitoring and troubleshooting in a container-centric world. Again, my name is Chris Crane. I'm VP of Product here at Sysdig. This is a topic that I think about and we here at Sysdig really think about all day, every day. And hopefully by doing that, we can save a lot of you the trouble of having to think about this too much. But this is certainly a topic that we have a lot of thoughts and opinions on. So I'm looking forward to sharing some of those with you today. The plan for this is to jump into some thoughts about the container industry and some best practices for how you can go about actually getting some visibility into containerized environments. I know it's a little hard to have a truly interactive session when I'm here talking at you, but please do feel free to submit questions throughout the talk. I'll try to keep this lighthearted and not too dry and keep everyone entertained, and then I'll make sure to answer some questions at the end. Any questions that I don't get to answering, we'll definitely follow up with after the meetup over email so we can get anything answered. Really quick background on Sysdig. We build monitoring and visibility tools, and we really specialize in containerized and Dockerized environments. We like to think that we're really the first and only container-native monitoring solution, a monitoring solution built from the ground up for microservice-oriented and container-driven environments. We have two product lines. The first is an open source tool called Sysdig, and the second is our commercial solution, Sysdig Cloud. I'm going to talk a little bit more about these later, but I want to spend most of the talk being as unbiased as possible and just talking about how you should look at monitoring from a container perspective, regardless of your monitoring vendor or solution of choice, whether it's open source or commercial. My understanding and my hope is that a lot of the people on this line are already relatively familiar with Docker and containers, so I'm not going to spend too much time on the background, but I want to touch on it quickly to make sure we're all on the same page. So I will start there. Hopefully we can all agree that there is at the very least a lot of hype around containers. Docker seems to be taking the ops and DevOps and dev world by the storm. This is a survey that's a little bit dated at this point from last summer, but came to the conclusion that the vast majority of enterprises are at least investigating the use of containers. Now I think the number of companies and organizations using containers in production is actually a lot lower than this, but that's partly why we're here, to help enable that transition. So why is there so much hype around containers? Well, I really believe it's for good reason. And in a nutshell, it's because containers are really enabling a new paradigm of software development. So when containers were first popularized by massively scaled companies like Google, I think the value proposition was largely around resource utilization. And Google has talked about how they've eliminated the use of entire data centers and billions of dollars of cost savings because of this, or at least millions. What's been interesting is over the past couple of years, I think this value proposition has really evolved, and that's what's driving a lot of the adoption in the market. So what we're seeing is that containers are really quite powerful at enabling continuous integration and continuous development, as well as general DevOps practices. So allowing developers and operations teams to share applications in a single portable transferable unit proves to be very valuable even at the business level in terms of getting new features and software out the door faster. And where this gets really interesting, I think, is in kind of the third evolution of value, which is containers as a building block for microservices. Now, this is where you start to apply orchestration tools on top and get a lot of the benefits of scale and automation that come from reorienting your architecture around microservices. I think we're just starting to see the beginning of adoption around microservices. I think 2016 has a good chance to be the year of microservices. But for those of you listening in today, even if you're still on step 1 or step 2 in terms of the value you're looking to get out of your containers, I think there's still a lot of value there, and it's very much worth looking into adoption. Now, this value, I would argue, is really stemming from the core technology behind containers. This idea that they are so lightweight and efficient, they are dynamic. Maybe most importantly, they are reproducible and portable between environments, both within an organization and between organizations. So that core technology is really important. But, and maybe there's always a but, there is a bit of a catch here. And that is that it turns out seeing inside containers is actually really hard. This is for a number of reasons. Not only are containers themselves kind of inherently black boxes, but you've also got the infrastructures that are being built on top of containers are becoming exponentially more complex, higher scale, dynamic, distributed across multiple environments, especially if you start moving towards microservices. And on top of this, you have a whole new ecosystem of technologies that are growing up around containers, including the scheduling and orchestration tools that I mentioned a minute ago, tools like Kubernetes or Mesos or even Docker Swarm, along with all of the networking tools and security tools and every other tool that's being developed along with monitoring to really be container native. All of this means that seeing into that environment can get a lot harder. So what we have is a bit of a catch-22 here, and this is really the question that I spend my time thinking about every day and that we're trying to solve at Sysdig. How do we enable our users and organizations that want to adopt these new technologies to innovate in their environments, to evolve their environments, but to do it in a way that does not sacrifice that visibility that you're comfortable with and that you're used to having in your production environments? So that's what I want to talk about today, how we can actually go about answering this question. I would propose that the answer to this question is what we like to call container native performance management, or CPM. The idea being that you're really rebuilding performance management from the ground up to be native to containerized environments and microservice environments. Now, I've talked to a lot of people in this industry over the past couple of years since we founded Sysdig, both container users, other vendors selling into the container ecosystem, other open source tools, and thought leaders. And we've come to the conclusion that there are really 3 key components to having a container native performance management solution. And these are components that I would really encourage you to look for in whatever solution you choose to adopt for your monitoring. The first is you're going to need to have full visibility into that containerized environment, and you're going to need to get it in a way that does not require instrumentation or extra burden on your containers. This is really hard, but it's very important that you actually respect that core technology behind the container, but you still want to have that full visibility that you're used to. On top of that, you need your solution to give you full awareness of all of these other container native technologies I was talking about, especially the orchestration tools that add extra layers of abstraction and complexity on top of your system. And finally, you want the whole user experience to be really oriented around containers and microservices. This is in terms of the UI and having dashboards and alerts that can keep up with the speed and dynamicism of containerized environments and the scale of it, where you've got hundreds or thousands or tens of thousands of nodes changing on a second or even a fraction of a second basis. But also adopting to a lot of the organizational changes that are coming along with DevOps and the move towards microservice architectures. You really want to have a user experience oriented around that. For the sake of today's conversation, I'm going to focus on step one, because really without this, nothing else matters. If you can't get the visibility inside the container, then it doesn't really matter what the user experience is or what else you can see. So I want to talk about this. We'll save the other two for maybe another session, or if you want to follow up afterwards, me or anyone on my team would be happy to talk to you more about this. But let's talk about how we get visibility into environments. So starting with what monitoring looked like in a traditional VM environment. Here's a kind of very high-level diagram. In a nutshell, you've got a monitoring agent. This agent is a small piece of software installed on each virtual or physical machine that you want to monitor, and it gives you full visibility into that machine. You can instrument the applications on the machine. You can see down into the system of the virtual machine. You can see out into your network and infrastructure. Really all good, and this has been the model for physical and virtual machine monitoring for many years now. Now where this gets interesting is when we start to wonder, how do we take this, this virtual machine agent, this agent that was designed for a VM world, and try to adopt it to the world of containers? How do we actually get visibility into the containers with this agent? I'm going to propose that there are three options. Hopefully the first two are pretty intuitive. The third may be less so. This is what we call monitoring as a microservice. And I'll get into this in a minute, but I want to talk about the first two before we get into that. So the first approach here is we could take that agent that was designed for a virtual machine, and we could install it inside each one of the containers in our environment. We could essentially treat those containers like virtual machines. This has one really significant upside, which is that suddenly we have full visibility into our containers. We can instrument the applications inside of them. They're no longer black boxes. We know everything that's going on. Unfortunately, there's a lot of downsides to this that make this approach pretty much unviable. Really what's happening is we're going to be undermining all of the benefits that we talked about that are coming from these containers that stem from that core technology. We're burdening those containers with an extra agent, and meaning we're not only going to have the software of the agent in there, but all of its dependencies, like languages, like we might have to put Java in there, or whatever else that's going to balloon up the size of that container. We're also undermining the portability and the reproducibility, because suddenly now if we pull a container down off Docker Hub, we can't just push it into production exactly how it looks like. We've got to add an extra software to it, which could potentially introduce security vulnerabilities, or at the very least just changes from the expected behavior, which means we're no longer getting that portability benefit of the container. So along with this and some scalability problems that I won't even go into, what we're seeing is that essentially no one in the industry is recommending this approach. No vendors are taking this approach. I highly suggest you do not try to put a monitoring agent inside each of the containers in your environment. Which brings us to the second approach. What happens if we put the agent in its own container and leave it outside of the containers that we want to monitor? This is great now because we're back to that, that approach of respecting the containers. This is no longer completely untenable. The problem is we're back to black boxes. We can't see inside our containers anymore. Now, to be fair, you can get a little bit of visibility. Docker containers, for example, will export metrics about themselves over the Docker Stats API, so you can see things, view and memory usage as reported by the container. But I think a kind of apt metaphor here is back to the world of VMs. Imagine this like hypervisor visibility for monitoring in your virtualized world. This would be like if we never came up with the approach of putting an agent in the actual VM, but rather only tried to monitor it from the hypervisor perspective, looking at what the VM was reporting from the outside. That's really what we're talking about here. On top of that, there's a lot of setup and maintenance issues that come with this. It is possible to actually configure plugins to go from the agent into the container to instrument the applications in that container, but they're really not designed to work that way, so you're going to be needing to configure them to containers which are spinning up and down all the time, changing IP addresses, changing networks, and it ends up being very brittle. On top of that, you've got scalability issues where a traditional VM agent is not really designed to be handling hundreds or thousands of nodes of information with thousands of pieces of metadata flowing through it. So a lot of monitoring agents are just going to break down, or legacy vendors are going to tell you that they really can't handle the level of data that's going to need to be supported here. So I'm not going to put an X on this one. I'll put a question mark because while I can't in good faith recommend that you do this, it's not the worst approach. This is maybe a good place to start. It's going to give you some level of visibility into your containerized environment at least. And this is the approach that the really every other monitoring solution in the market is taking right now. I think there's a better way though, and we here at Sysdig arrived at this conclusion by asking this question of what if we tried, rather than starting from a virtual machine agent, what if we tried to actually build a monitoring solution from the ground up for a containerized environment? And what we came up with, and maybe you see where this is going, is a solution that gives you a bit of the best of both worlds. So you see here what we imagine this looks like. The idea is you have a monitoring container that's deployed in your environment. It's separate from the containers that you want to monitor, and really acts as just another microservice running in your environment. This is why we call it monitoring as a microservice. So it's its own independent container, but, and this is the most important part, it can still see inside all of your other containers and give you full visibility into those containers. So what does this mean? It means it actually aligns with the container and microservice principles that we've talked about. It doesn't instrument your containers, but we're still going to get 100% visibility into everything happening in our environment. That means into the applications inside the container. That means into our orchestration tooling and our other container native technologies, into the host operating system, whether that's a physical or virtual machine, out into our network and infrastructure, really the whole thing. It's also got to be highly scalable, highly dynamic, ready to spin up and down just like any other container in your environment and be deployed on thousands of nodes and process thousands of bits of metrics and data and information. And maybe most importantly, it's really got to work with a minimal amount of setup and configuration so that this can be automated, whether with the configuration management tool or with an orchestration tool if you're moving in that direction. And this is really why we call it monitoring as a microservice. So this is the approach that I suggest you take. This is what I suggest you look for in any monitoring solution that you're looking to build yourself or purchase from a vendor. And I want to talk a little bit now about our personal approach to this, the Sysdig approach to monitoring as a microservice. Because this is not just a theory. This is something that we've actually implemented. It's something that you can deploy in your production environment today. It all really comes down to the core technology behind our products, which is this open source technology. And the way it works is we're going to actually instrument the host operating system in your environment. So here we're looking at that operating system. You can see the kernel of the OS. You can see a number of applications on the left there running on this operating system, as well as containers. Within those containers are applications. All of these applications are communicating with the shared kernel. This is the kind of the core technology of containers. What Sysdig is going to do is insert a thin layer of instrumentation into the kernel there, which lets us, in a very low overhead, transparent way, capture all of the activity happening on this machine, whether it's from an application inside of a container or not. And the kind of special sauce here, the secret sauce, is that we know which container all of this activity is coming from, and we can see inside the container. As some of you may know, containers are really just and abstraction at the kernel level based on facilities like C groups and namespaces. So by seeing the activity at the kernel level, we can actually see inside the container as if it wasn't even there. We're then able to ingest all of this data up into our monitoring container, and in the case of the open source tool, drop it into a trace file so you can analyze it later if you'd like. On top of this core technology, we've built our 2 products. On the left, you can see Sysdig, our open source command line tool. This is going to work on an individual machine. Relatively technical tool, but surprisingly easy to use. I like to compare it to tools like HTOP or LSOF or other classic Linux tools. The idea here is we're going to give you really powerful troubleshooting capabilities. You're going to see everything that's happening on that machine, and I mean everything, in a really simple, easy-to-use command line interface. Then what we've done is taken that single machine technology and built a fully distributed monitoring platform on top of it, and that is Sysdig Cloud. So in the case of Sysdig Cloud, we're going to collect all this information from each machine that you have instrumented with our monitoring container, aggregate it all together, put some intelligence on top of it, put some visualizations on top of it, and really deliver you everything that you'd expect from a modern cutting-edge monitoring solution. So dashboards and alerts and a whole lot more. So with that, what I'm going to do is jump over and actually show you what Sysdig Cloud looks like. All right, hopefully my browser is coming through clear here. So what we're looking at now is the Sysdig Cloud web application. Here I have a demo environment. In this case, it's running on AWS. And I want to start out with this visualization here that we like to call the map view or the topology view. I think this pretty clearly demonstrates a lot of the concepts we were just talking about there before with monitoring as a microservice and container vision. So what you see here is in this demo environment, we're actually able to automatically map the logical dependencies of your application. So the way this works is you're going to take the Sysdig Cloud monitoring container, you're going to install it on each one of your hosts, and all you have to do is log into the application here, and you're automatically going to see this level of visibility. We're able to piece this all together without any configuration, no setup. You just come in here and see it, and here it is. So we can see traffic is coming in from our clients, hitting our load balancers, in this case ELBs on AWS, going through and hitting our front end here where we've got 3 servers running, and then out to the various data layers that we're using in this application. Now where this gets more interesting is I can actually start to zoom in. We like to call this Google Maps for your infrastructure because you can start with that bird's eye view and then start to dig down into the nitty-gritty in your environment. So here I see the actual 3 EC2 instances that are running in this front end here. And I can actually keep going all the way inside of these EC2 instances. Now I'm seeing individual processes and individual containers, as marked with this Docker label, running on this machine. And I can even explode out these containers and see the individual processes running in each container. So now I see I've got an HA proxy container, which is distributing load across 4 WordPress containers. So once again, I really want to reiterate here, nothing else is instrumenting these containers. We can see here Apache is the only process running in this Docker container. All you had to do was deploy the Sysdig monitoring as a microservice onto this node, and you automatically get that really deep visibility all the way down to the process level within every container in your entire environment. Now, with this level of visibility, we can start to give you more of that classic monitoring experience, but do it in a really modern way for your containerized environment. So if I scroll down here, I see what hopefully looks like a pretty familiar dashboard. I'm looking at things like CPU and memory and network traffic. But in this case, I'm looking at it on a container basis, specifically broken out by container image here, although we could break it down on an individual container basis, of course, as well. What I want to point out here is this type of data, this type of system data, basic system data like CPU and memory, this is really just the tip of the iceberg of what you can get from Sysdig Cloud. But this is 100% of the visibility that you're going to get from any other monitoring tool that's based on a legacy solution, an agent that was designed for a virtual machine. Because this is all the data that's going to be exported by those containers from the outside. So if you're okay with a black box container, this is the data that you can get from any other solution on the market. If you want to do really container native performance management though, if you want to do the type of performance management you're used to in your legacy environment, you probably want to know what's actually going on inside the container. And I'll show you what that looks like here. Now we're looking at a dashboard specifically oriented around the Cassandra application running in this environment. So we can see application level metrics, in this case pulled from Cassandra as well as the underlying JVM, things like heap usage and thread count that are powering Cassandra. Now this is specific for Cassandra. You may have other applications running in your environment. Of course, Sysdig Cloud is going to support dozens, it might be up to 100 different applications out of the box now. And the most important part is that there's no setup and no configuration. We're able to automatically detect every application running in your environment, similar to what you'd experience with service discovery within an orchestration tool. We automatically detect those services. We automatically put the right hooks in them, put the right plugins into them, and automatically start pulling that information out. So if I spin up a new Cassandra container anywhere in my environment, I'm automatically going to start getting data from it here in my Cassandra dashboard. I'll show you what this looks like for another type of application. Let's look at the front end tier within this environment where I've got another dashboard built. So here we're looking at that web tier. And again, we can see high-level things like CPU, memory, network at a container basis. But we're also going down inside that container. We're breaking it out on a process-by-process basis. So really deep granularity. But maybe more importantly, we're starting to, again, to give you those application level metrics. So we're giving you things like response times correlated with that underlying resource usage. Here we're looking at data for HA proxy and the HTTP traffic that's passing through my HA proxy server. So here I can see things like what are the most requested resources in this environment and what are the slowest resources. So really deep application level visibility here, again, with no instrumentation, no need to instrument my code, no need to instrument my containers. And another way that this becomes really powerful is when you start to layer orchestration tools on top of this, we're able to extract the metadata from that orchestration tool. So let's just imagine that this HA proxy container was actually deployed by Kubernetes in this environment, and I had dozens of HA proxy containers scattered across dozens of underlying physical servers. None of that matters because we're able to understand the context of Kubernetes, and we could provide you your HA proxy dashboard here, which would show you the performance at the holistic level as well as down to each individual container, no matter where those containers are throughout your environment. That's what I mean when I say container native performance management. Coming up on half an hour here, I want to show you one more feature, and then I'll pull up and see if there's any questions I can answer. I want to talk a little bit about how this technology can be used for a troubleshooting scenario, because we've been pretty focused on monitoring so far. So I'm going to jump over to the alerting tab here, and you'll be able to see a string of alerts that have been fired in this environment. And if I click into this specific one where we had a network traffic spike on Mongo, we can see the actual spike happening here with the network traffic going up to over 10 megabytes per second. But what happens if I want to actually troubleshoot this and get to the root cause of the problem? Well, what I can do is click on this button, Explore Notification. What this is going to do is drop me back in time to the point of the alert and give me all of the information that was collected across my entire environment at that point of time, all correlated together, so that I can dig through that context and try to get to the root cause of the problem. So you'll see here, now I'm looking at yesterday at 10 a.m. I'm zoomed in on my Mongo tier, and now I can see this spike in Mongo traffic. I can also see other alerts that were triggered here and see if anything here might correlate to the problem. But I'm going to approach this a different way. So right now we're looking at network traffic, and it's broken out by the actual port that it's on. So we see that it was actually port 80 that was the cause of the spike. What if we, oh, clicked the wrong button there. Sorry about that. Let me get back to where I was. Explore notification. What if I segment this by process instead, because you saw before we have process level information. Now we can see the actual name of the process that was causing this problem. It was this main process. And I can go even deeper. I can see the command line that spawned this. If I change this to a bar chart, it's a lot easier to read. Now I see it was actually a Python process. Now this is a demo, so of course it was a script designed to stress the system. But hopefully you can see how quickly, within a couple seconds, I was able to get to the actual cause of that spike in network traffic. And we can go even further. If I jump over to my views here, I can start to apply really deep system level views and get an even better idea of what was going on. If I go to an overview by process here, I see a breakdown, and this is across my entire Mongo cluster, remember, of everything that was going on here. I see all the processes running. Looks like CPU and memory are fine. When I get down to my network connections and bytes, I see that spike as expected. Now this is interesting though. There was also a spike in the file I/O. I can dig into this even further as well. I can go to the top files on my system. Now I'm looking at top files across that entire cluster of Mongo containers. And here I can see there was a file here that was spiked in correlation with that network traffic. This is actually based off of a use case that we learned from one of our users where they had a process get caught in a loop writing to a log file in a very unique situation. So it was only happening every couple of weeks. The log file would explode, bring down the server, and they spent months trying to figure this out and what was bringing the server down. And then within just a couple hours of installing Sysdig Cloud, they were able to trace it down to that individual log file that was bringing down the system. I think it's worth pointing out here that not once did I have to SSH into a machine. I never had to go sorting through logs on a machine to figure out what happened. I never had to pull up classic Linux tools like top or PS that really start to break down and not function well in containerized environments. And I never even had to go try and reproduce the issue because I had all the information here in Sysdig Cloud all the way down to the process and port and file level, so I could go troubleshoot this issue in some real depth and get to an answer really quickly. There's a lot more that we can do, of course, but I want to leave it at that for now. Hopefully this was a helpful introduction to Sysdig Cloud and what it means to try to monitor and troubleshoot in a containerized environment. I'm going to throw up some contact information for me here. Please don't hesitate to reach out. Again, my name is Chris. You can see my email here. You can find me on Twitter. You can also reach out to the Sysdig team on Twitter over email. And please don't hesitate to go check out our open source tool, Sysdig, at sysdig.org. And Sysdig Cloud, you can sign up for a 2-week free trial at sysdig.com. Mention this meetup to our sales team, and we'll give you 20% off if you do end up making a purchase. Let me jump over to the questions now and see if there's anything to answer. Yeah, it looks like we've got a couple here. Give me 1 second. I'll read through and see if I can give you guys an answer. All right, so the first question is, the open source tool with the kernel instrumentation that you described seems like it could be used for non-container environments as well. Do people do that either with the open source product or the cloud product? The answer is absolutely yes. So for the purposes of the topic today, I've really focused on monitoring containers. But in the case of Sysdig's technology, both the open source and commercial tool are really technology agnostic. As long as you're running in a Linux environment, we're going to be able to monitor and give you visibility into any technology running on there, whether it's in a container or not. Next question, another good one. Someone is wondering what's the overhead of the container or the kernel instrumentation. There are a couple ways to answer that, but really the short answer is that the overhead is negligible. It's what you would expect from any other monitoring tool. So in the case of the Sysdig Cloud container, we're talking about a couple percent CPU. The resource utilization is capped at 5%, so it should never be a problem with bringing down your system. The kernel instrumentation itself, where we're actually capturing the system calls, is extremely, extremely efficient. So that'll have actually no, or I should say very, very negligible impact on the performance of your applications at the kernel level. Another question here, how does the cloud service deal with containers continually coming and going from a technical perspective and from a cost perspective? Yeah, this is an interesting one. So containers definitely do tend to come and go very frequently in modern containerized environments. From a technical perspective, as I talked about a little bit, we're going to automatically detect those containers when they spin up or down, so there's no configuration or setup you have to do. We're also going to collect metadata from those containers, so if you have Docker labels on them, or if you're using an orchestration tool that's applying metadata to it, we'll automatically ingest all of that so that we can put those containers and their information into the right alerts, into the right dashboards for you automatically. From a cost perspective, open source, obviously no cost there. For Sysdig Cloud, we charge on a per host basis. So it's going to be $20 per host per month for the recurring subscription, and that includes all the containers on that host. So no cost as containers go up and down. Another question here, how to monitor across availability zones or data centers where I'm doing worldwide distribution, or where are the Sysdig scalability inflection points? Is kind of the backup question. So we should really have a personal conversation about the type of scale that you're talking about, but Sysdig Cloud is absolutely designed to work across environments. So not only is it going to work on-premise, in a private cloud, in a public cloud, but it's going to work across all of those environments, potentially in combination if you want. So we have plenty of customers who are running in multiple public clouds or who have a data center and a cloud solution that they want to monitor. All you have to do is drop our agent into any host. That host could be anywhere, and we're going to be able to aggregate the data from it. I should also point out that Sysdig Cloud is available both as a SaaS solution or as an on-premise solution. So if for security or compliance reasons or any other reason you need to have the entire appliance behind your firewall, we can provide that for you, and would love to follow up with anyone if they're interested. It looks like we've had a couple questions about getting metrics and data out of Sysdig, so piping them into another tool like Grafana, and potentially, or an in-house monitoring solution that you already have where you could do other manipulations on the data. The answer is yes. All of Sysdig Cloud is built on top of APIs. We're in the process of opening up those APIs to the public. Certain functionality is already available and documented in the public API. Other functionality is still in beta, but will hopefully be GA very soon. If you're interested in working with us on those APIs and getting beta access, absolutely let us know, and we can do that for you right away. It looks like that's all the questions we have to answer today. Again, if anyone else has any, please follow up with me. I love talking about this stuff, and I want to make sure that all your questions are answered. These could be questions related to Sysdig or not related to Sysdig at all. Happy to talk about containers or container monitoring in general. And with that, I will say thank you everyone so much for joining late in your evening, and I hope this was helpful. And thanks again. My name is Chris. Have a good night. Bye.